Puffy planets lose atmospheres and become super-Earths. Exoplanets come in shapes and sizes that are not found in our solar system. These include small gaseous planets called mini-Neptunes and rocky planets several times Earth's mass called super-Earths. Now, astronomers have identified two different cases of mini-Neptune planets that are losing their puffy atmospheres and likely transforming into super-Earths. Radiation from the planet's stars is stripping away their atmospheres, driving the hot gas to escape like steam from a pot of boiling water. The new findings help paint a picture of how exotic worlds like these form and evolve, and help explain a curious gap in the size distribution of planets found around other stars. Mini-Neptunes are smaller, denser versions of the planet Neptune in our solar system, and are thought to consist of large rocky cores surrounded by thick blankets of gas. In the new studies, a team of astronomers used NASA's Hubble Space Telescope to look at two mini-Neptunes orbiting HD 63433, a star located 73 light-years away. And they used the Keck Observatory in Hawaii to study one of two mini-Neptune planets in the star system called TOI 560, located 103 light-years away. Their results show that atmospheric gas is escaping from the innermost mini-Neptune in TOI 560, called TOI 560.01, also known as HD 73583b, and from the outermost mini-Neptune in HD 63433, called HD 63433c. This suggests that they could be turning into super-Earths. Most astronomers suspected that young mini-Neptunes must have evaporating atmospheres, said Michael Zhang, lead author of both studies and a graduate student at Caltech. But nobody had ever caught one in the process of doing so until now. The study also found, surprisingly, that the gas around TOI 560.01 was escaping predominantly toward the star. This was unexpected, as most models predict that the gas should flow away from the star, said Professor of Planetary Science Heather Knutson of Caltech, Zhang's advisor and the co-author of the study. We still have a lot to learn about how these outflows work in practice. New clues to missing link in planetary types. Since the first exoplanets orbiting Sun-like stars were discovered in the mid-1990s, thousands of other exoplanets have been found. Many of these orbit close to their stars, and the smaller, rocky ones generally fall into two groups, the mini-Neptunes and super-Earths. The super-Earths are as large as 1.6 times the size of Earth, and occasionally as large as 1.75 times the size of Earth, while the mini-Neptunes are between 2 and 4 times the size of Earth. Planets of these types are not found in our solar system. In fact, few planets with sizes between these two ranges have been detected around other stars. One possible explanation for this size gap is that the mini-Neptunes are transforming into the super-Earths. The mini-Neptunes are theorized to be cocooned by primordial atmospheres made of hydrogen and helium. The hydrogen and helium are left over from the formation of the central star, which is born out of clouds of gas. If a mini-Neptune is small enough and close enough to its star, stellar X-rays and ultraviolet radiation can strip away its primordial atmosphere over a period of hundreds of millions of years, scientists theorize. This would then leave behind a rocky super-Earth with a substantially smaller diameter, which could, in theory, still retain a relatively thin atmosphere similar to that surrounding our planet Earth. A planet in the size gap would have enough atmosphere to puff up its radius, making it intercept more stellar radiation and thereby enabling fast mass loss, said Zhang. But the atmosphere is thin enough that it gets lost quickly. This is why a planet wouldn't stay in the gap for long. Other scenarios could explain the size gap, according to the astronomers. For instance, the smaller rocky planets might have never gathered gas envelopes in the first place, and mini-Neptunes could be water worlds and not enveloped in hydrogen gas. This latest discovery of two mini-Neptunes with escaping atmospheres represents the first direct evidence to support the theory that mini-Neptunes are indeed turning into super-Earths. Signatures in the sunlight. The astronomers were able to detect the escaping atmospheres by watching the mini-Neptunes cross in front of, or transit, their host stars. The planets cannot be seen directly, but when they pass in front of their stars as seen from our point of view on Earth, telescopes can look for absorption of starlight by atoms in the planet's atmospheres. In the case of the Mini-Neptune TOI 560.01, the researchers found signatures of helium. For the star system HD 63433, the team found signatures of hydrogen in the outermost planet they studied, called HD 63433c, but not the inner planet, HD 63433b. The inner planet may have already lost its atmosphere, explained Zhang. The speed of the gases provides the evidence that the atmospheres are escaping. The observed helium around TOI 560.01 is moving as fast as 20 kilometers per second, while the hydrogen around HD 63433c is moving as fast as 50 kilometers per second. The gravity of these mini-Neptunes is not strong enough to hold on to such fast-moving gas. The extent of the outflows around the planets also indicates escaping atmospheres. The cocoon of gas around TOI 560.01 is at least 3.5 times as large as the radius of the planet, and the cocoon around HD 63433c is at least 12 times the radius of the planet. The observations also revealed that the gas lost from TOI 560.01 was flowing toward the star. Future observations of other mini-Neptunes should reveal if TOI 560.01 is an anomaly or whether an inward-moving atmospheric outflow is more common. As exoplanet scientists, we've learned to expect the unexpected, Knudsen said. These exotic worlds are constantly surprising us with new physics that goes beyond what we observe in our solar system. The findings are being published in 2 separate papers in the Astronomical Journal. In this artistic animation, the Mini-Neptune TOI 560.01 is shown transforming into a super-Earth. The planet is about 2.8 times the size of Earth and has a puffy atmosphere, made up of mostly hydrogen and helium. Observations with the Keck Observatory in Hawaii revealed that helium is escaping from the planet. Scientists say that the planet could lose the vast majority of its atmosphere after several 100 million years, leaving behind a type of large rocky planet called a super-Earth.